Alrighty, good morning, everyone, and thank you for joining me today. My name is Brian Mongkolpoonsuk, Customer Success Manager here at KETIV Technologies, and happy Friday. Today, we're going to be going into a lot of 3D printing when it comes to Fusion 360, and this is personally a subject that I'm pretty familiar with just because I do a lot of 3D printing myself, and I use my own 3D printer to help create some content for this webinar today. So I'm going to be sharing my Zoom video so you guys can see some of those prints that I made. But we'll be diving into the prints that are needed for snap fit designs. And when we talk about snap fit, there are these different types of snap fits, like that buckle that you see there in the middle. We have that like baby door lock, I would say, on the bottom left, where to stop them from getting into your medicine cabinets. And we have like cylindrical ones on the bottom right. Today we'll be going into these examples here, where it's pretty linear. Like the first bottom left, there is like a cylindrical press fit, and it's just a matter of, okay, what exact tolerance works. And I know everyone has a different printer, everyone has different settings. So just the tolerance of your own printer variables can vary drastically depending on what kind of filament you use and things like that. So we'll be going into some of those topics. The box fit here at the top middle is just going to be a straight linear fit. And then the two here on the left-hand side are more of like a latch design that I made for this box in particular. Kind of if you compare it to like a pencil box, if you ever used those back in the days, where the plastic kind of comes down and bends a little bit and then it latches onto it. So we'll be going into these examples today. And I wanted to just give you some information of like the printer settings that I'm using. I'm using pretty much the default one, the default printer settings from the Flash print slicer that I use. I can go into more details of this afterwards, definitely. But if you want to shoot me an email and share with me your settings or have that conversation, I'm more than happy to do so. But these are out of the box settings. Besides the nozzle head, I have mine at 210 degrees Celsius to match the filament I'm using, which is this Overture brand PLA plastic. The printer I'm using is a Flash Forge Finder. There's no heated bed on it, so just keep that in mind when it comes to my end result, maybe versus your end result. So with that said, let's go ahead and go into our first example here. I have an Arduino box or an Arduino Uno that I created an enclosure for. So let me go ahead and pull up Fusion 360 and quickly create the base for that so we can start getting our gears grinding for usage of Fusion 360, of course. So I'm not going to take too long on just a little design process. Hopefully you can learn some of these processes from other videos that we've done in the past. This is our 60th Fusion Friday, or Fusion AVA, Autodesk Virtual Academy is what we technically call it now. And let me go ahead and offset that. So yeah, definitely check out our other videos as well that are on YouTube. But yeah, we'll go ahead and create the base of this design. And for those of you who have worked with assemblies inside of Fusion, this is an interesting find, and it might have been out for a while, but notice how when I want to create another component, I accidentally already created this body and these sketches. And typically what we recommend is creating a component right away, right? And then putting all those sketches and bodies in this component. Whereas I already created the bodies and sketches, I don't want to have to redo everything. So technically you don't have to. So if I go to create a new component, I can actually just grab this body here, drop it in, right? And I can also grab the sketches now and drop it in. And it kind of packages it all together. So now I don't have to start from scratch, or I don't have to have a flawed assembly. I have my sketches and features inside this base here, which is really nice. And I can go ahead and now create the lid component. because of the way I'm supposed to have done it. But I mean, it was lenient in the way where it gave me the ability to put the sketches and features in that base there, or that body. All right, so lid number 1 here. Let's go ahead and project. So I'm hitting keyboard shortcuts. So you may be curious as to why I'm selecting these objects, or these tools are just popping out of nowhere. It's because I'm selecting it on my keyboard. I'm switching between O for offset and P for projection. Those are the 2 primary tools to create these tolerances here. So I'm just going to place a value in here, and I'm going to reference the original, or this 10 thousandths of an inch offset by clicking on it. So it gave me a D41. That's what that dimension is. And then I'm going to add, let's see, 2000. That's too much. Then I'm going to add 1 thousandths. Let's do 1 thousandths of an inch. Sure. All right. And now we can go ahead and extrude this down. So this will be the part that's making contact with my base body. And this part of the lid will be making contact with this base body. Now let me just draw the top part of the lid. And when I mean draw, I mean just reference what I already have, because why would I need to do more work? Oops. All right, so now I have that lid at top. And just to add one more little feature to this, because it's going to be hard to grab with your fingers to lift this lid off in case it does snap fit tightly. Let's go ahead and create a little cutout for our fingers to go through. And I'm just going to cut through everything, except I'm going to deselect the lid to cut through. So then it doesn't cut through the lid at all. It just cuts through the bottom base. And since this is a component, these are components, I can click with my mouse and drag and pull them apart from each other so I can kind of see what it's like on the inside. I'm going to do Control Z to undo that, so I can just put that back to where it was. But if you want to keep it the way it is out here, you can go ahead and capture that position at the top there. But this is exactly what the design I wanted to make. So I'm going to go back to the PowerPoint, because that has a table that I've done some testing on with some of these prints. So I printed it out with 20 thousandths of an inch, 10 thousandths of an inch, 7.5 thousandths of an inch, and 5 thousandths of an inch. And you can see my results for each one. I will go ahead and share my camera now. All right, so hi, here I am. Here's the Arduino Uno board that's inside the print I made. And the first one is I don't know if you can see this, leave in the comments if it's hard to see. But here is the 20 thousandths of an inch. And when I put that on, you can kind of see that it's loose, and I could just easily lift it off. That's not going to work, right? So then we go into 10 thousandths of an inch. You can hear that it snapped a little bit. It's fine if you try to flip it upside down, things like that. So this is fine, but if you really kind of pull them apart from each other, it's not perfectly going to close it shut. So it depends your design case. If you want to have it for really, if you want it to be more snug fit, maybe you can go with something like the 5 thousandths of an inch lid. And if you hear there, I put a little bit more pressure onto it. And okay, it is going to come up a little bit, but I mean, it's a little stronger. You can definitely feel that it's a lot stronger than the 10 thousandths of an inch one. So those are some of the values that I got for my testing. So do what you want with that information. And this is for that kind of I just made. So again, there's a lot of different variables that come into this. But this is just an example of a design that you can utilize with the 5 thousandths of an inch or 10 thousandths of an inch design for the model. And a similar scenario for cylindrical press fits in terms of how tight or how loose the snap fit is. But the difference between that I discovered for cylindrical or different size prints. One is that there's a discrepancy when you are designing a cylindrical fit here. Let me just make sure. Okay. When you're designing a cylindrical fit here. So when the extruder head goes around the outside of the cylinder, it has to stop at a certain point in order to either go to the next level or start shading in. And that certain point, if you can see in this model here, causes the discrepancy in the print. And that will cause the tolerance to be skewed, and it will cause the fit not to be as accurate as maybe something more linear like you just saw. So that's, and it shows in the smaller diametered cylinders when I use the press fit example, because the smaller ones are more sensitive to any tolerance issues, and that's why it affected it first. So as you can see here, for the 1/4 inch, it becomes tight at 7.5 thousandths of an inch, whereas the 1-inch diameter one didn't really notice that change as much. It was still relatively loose. But when you make that, so yeah, so essentially 1/4 inch or smaller prints are more prone to tolerance issues. Okay. Another thing about cylindrical print layouts, if you're trying to print horizontally, you're not going to have a good time. That's because if you see here, this is you bringing the model into the slicer. If you go into the middle here, when you actually slice it, it's not going to give you that perfect circle. It needs a little bit of a foundation, the slicer does, in order to print your models more. In order to print your models in general, it needs some sort of foundation there, which is why it looks like this. And it, again, this is going to be inaccurate. And the smaller it is, the more prone it is to having those issues. Even with the hole that is supposed to go into has that issue as well. So just keep that in mind. You want to go ahead and print it out as maybe vertically if you can. If it's a very long cylindrical print, you'd have to decide for yourself and play it by ear. But look how this is way more smooth than the previous image, because this is being printed vertically, and you're going to get better results with this kind of layout. Okay, so let's go into our last example here, which is the latch design for the snap fit like pencil box, quote unquote. And I kind of got the idea from a pencil box, because in pencil boxes, the top part of the lid, it comes down with the little latch that kind of hooks onto this little nub of plastic that sticks out the bottom. I did a similar design, but it's kind of vice versa. And the reason I did it vice versa is because I wanted this to be printed without any support structures. If you have any support structures in your design or in your prints, it's going to, and if it is around this area too, where it latches together, it's going to interfere, of course, with the design, unless you can somehow perfectly cleanly get off the support structure, which would be very difficult. But you can, or maybe if you use sanding or something like that. But if you're trying to get a print without having to, with using as least amount of that as possible, then I would go for this design here. So let's go ahead and get into that with Fusion once more. So I'm going to save us the time and just have this box ready to create that latch. So because right now, this box is, oops, that's a spoiler. Okay, this box is ready to it's not connected by anything yet. It's just flopping onto the top of the surface. It doesn't have that Arduino board box fit here. So let's go ahead and start with a mid-plane design. Let me go ahead and activate my component first. And let's go ahead and create a mid-plane at the center, because that's where I want my latch, or in this case, my nub to be. And I'll go ahead and start the sketch here. And I will hit P for project to project that part of my geometry. And I'm going to go ahead and draw a line out in space. And I just happen to make this 25 degrees. You can use whatever value you want, but mine just happens to be 25. And I want this the length of this to be 0.19. It just happens to be that. Again, it's depending on your design in general. And let's go ahead and now we have our little nub here. We can technically add fillets if you want here. I like to add it at the 3D model level just because it's easier to see how I would want my fillet, because right now it's just a sharp edge, right? So it'll be 1/2 inch that way. And then I want to make this symmetric to go both ways. So I have my little nub there that I'll now add some fillets. And another fillet, F for fillet. And we're off to the races. So we have our nub here at the top part of the lid. Let's go ahead and dive into the base now. So in the base, I'll create another mid plane. Maybe I could have just created one and referenced it, but I'm just going to create another one. And I want to project again. I want to project the geometry I just made, and then maybe this part of the model as well. All right, and now knowing what we know from that table that we tested earlier, we're able to offset, and I think it was 10 thousandths of an inch that started to kind of snap together. So I'll kind of start with that here in this design. And then so I'm able to have a little bit of a gap between the model, but it's such a small gap that it'll do that, a similar snap fit to the original or to our example previously. Now let me go ahead and do one more offset. Actually, I'm going to turn off chain selection because I don't want the whole thing selected. I just want this edge right there to be selected, and it will be, and this edge will be this distance plus 0.2. No, it's not. It was not 0.2. It's 0.1. Just to give me some distance, some thickness to this latch here. And then I'll go ahead and extend the edge here to this projected edge here. And I do want to do the same onto this side as well. Modify, extend, there we go. And it's not giving me a profile, so I think it's because this guy down below here is not extended all the way. For whatever reason, it's stopped right there. So let's go ahead and extend it one more time. And now it's highlighted light blue in the middle there. So now I have a profile I have ready to extrude. Let me just clean that up right there. I'll hit T for trim and just select that, or I can just drag and draw over it. So now I have this angle that's referencing or that's parallel to that. So now we can go ahead and hit E for extrude. And we can extrude this out, again, the 1/2 inch both ways. And I do like creating my fillets in the 3D space here. So I'll create a small little fillet for that edge and another fillet for this edge. So it's hard to put into words the design over here as to, is this the right tolerance for it? Is this the right tolerance for it? Is this the right tolerance? It was a little bit of a trial and error for me. And I think that would be the same for you, depending on your latch design. But if you want to follow this design that I have already, I went ahead and just went with 0.15, if you saw there, or 0.015. Because once this lid goes up, once you pull it up, this latch here is going to push right. It's going to push up and right a little bit. So that's where it's going to be holding it in place. But I'm giving it this fillet here to kind of give it some leniency. So when it does go up, it can slide off of this model here. So let me go ahead and activate that. So although right now, if I were to move this up with my mouse, it does overlap with each other. Just know that with plastic in general, it will bend, right? Obviously. So just imagine this part bending out a little bit, and then you're able to lift this up as need be. So that that's generally the whole idea of this latch design here is for to cater to that bend, and to make this maybe look a little bit more smooth down below here. I can maybe add a fillet, so maybe it won't snap off if I bend it a certain way. Maybe you can add some more density or infill to your prints in general in your slicer workspace, so it's tougher around these edges. And you can even sand this. Like, that's what I started off. If this was too tight of a tolerance, I would bring either sandpaper or this metal thing that I'll show you guys in just a second here, to kind of clear this off in case I don't want to print it again if I'm just happy with the first print I got. So let me go ahead and show you my box. Let me share my video here. So here's the finished design of this box. And if you see around here, this is where I can just lift it up. And I sanded this down a little bit because I wanted a little bit of an easier lift off of the hinge or of the latch. But yeah, as you can see, it's kind of coming in and out, and then it has that little snap noise to kind of lock it into place. And to sand it down, I happen to just have this metal filer with me. I think this works really well. Be careful not to sand too much because you can never add material back to it. You can only take away from the material. But yeah, sandpaper should work as well. It might just take a lot longer. All right. So let's go back to do a recap. So essentially an Arduino closure, the Arduino enclosure works well within 10,000ths of an inch to 5,000ths of an inch, which is good tolerance. Just a reminder, the smaller prints that you have, the more vulnerable it is to tolerance. So just keep that in mind when you're trying to use the same tolerance for a large model and a small model. It's not going to be the same. If you have cylindrical prints, print them vertically, not horizontally, because of the reason of it not printing a perfect circle, as you saw in the images. Be mindful of supports when printing with something like a snap fit, because any supports that's in between yours where it's supposed to be snapping is not a good support unless you clean it up really well. But I would prefer not to have to meddle with that. And to clean up the snap fits for maybe like a latch design, maybe sand it down. So that's pretty much it. I wanted to kind of condense this. I know I was speaking a little fast here, but I wanted to give you as much information and save everyone's time here. But I wanted to share with you guys. I personally like this topic a lot, and I hope you guys did too. If you have any questions, feel free to leave those in the chat room. I think I see one come in actually. Okay, so what kind of 3D printer do I use? Do you recommend any printers for beginners? I use the Flash Forge Finder. That was actually in the, let me show that again in the second slide here, or sorry, a few slides in. Yeah, I use this red one at the bottom right here. And this was actually my first, my first printer of 4 years ago, I'd say. So I would run this printer. And you're saying, do you recommend any printers for beginners? I would recommend this printer for beginners. I was able to print like 15 minutes out of the box, which is really nice. With every printer, there's a learning curve, Adam. So definitely just keep that in mind. I had to change like the nozzle head one time, and I had to open it up and fix a thing here and there over the course of those 3-4 years. But overall, I still recommend it. It's still working today, and I still use it for all these prints that you saw today. I would also just pay attention to the type of filament that you're using as well. They have nozzle temperatures that I discovered a year or two in. So just keep that in mind, what temperature you're printing at, because it might not be the printer that's the issue. It could be the filament that could be the issue of why it's coming out weird. These filaments have different print melting temperatures to them. Good question. All right, give another like 20 seconds here. for any more questions. If you like this kind of content, definitely let us know of printing, 3D printing. I've done one in the past of the 3D printed threads. I actually mean to post that link in the chat room. So let me go ahead and do that before everyone leaves here. Sorry about that. Okay. So yeah, that one was one on 3D printing threads and how you modify threads inside of Fusion, or there's also one on an inventor that I did on our Thursday webinars. So whether you use Inventor or Fusion 360, I modified kind of threads in both of those if you're 3D printing threads. But overall, if you can use a metal one, use if it's something like a dowel pin, maybe you can use a plastic one for that, but or like a regular pin, a metal pin. If you find the right size, or if you have the right size with you, maybe just use the metal one. But if not, you can definitely just 3D print one. Just keep in mind the tolerance. All right. Doesn't look like any other questions are coming in. So I appreciate everyone's time, and I look forward to seeing you guys in the next webinar. Thanks for watching.